here we go. Students will be able to find the position of particle given the velocity. A calculator is required, so we're going to do a lot of this with the calculator. An object moving along a curve in the xy plane has position x of t, y of t, which indicates that this is parametric. At time y greater than or equal to 0 with dx dt equal to 3 plus cosine t squared. So they give us a derivative of x. The derivative dy dt is not explicitly given. At time t equal 2, the object is at position 1,8. So they tell us, they anchor it down. They tell us at t equals 2, we're at 1,8. Find the x-coordinate of the position of the object at time t equals 4. Well, we're going to start when t equals 2. We're going to start at 1. We're going to do 1. And then we're going to add on the displacement, how much the particle moved, is at least the x part of it. We're going to integrate from 2 to 4. We're going to start at 2. We're going to integrate to where they want. So this is the displacement from 2 to 4. We've anchored it down at 1. What's the displacement? And then we need 3 plus cosine of t squared. And taking cosine of t squared, that's going to be kind of difficult to get the integral. That's where the calculator comes in. So we go math number 9. We're integrating from 2 to 4. Don't let me forget to add 1 to this. 3 plus cosine of x squared. X. Enter. And then we add 1. Add 1. 7.133. 7.133. So that's the x-coordinate when t is equal to 4. At time t equals 2, the value of dy dt is negative 7. So they don't give us the equation for the derivative, but they do give us a value for it. Write an equation for the line tangent to the curve at the point x2, y2. Don't we know the point at 2? It's 1,8. So the line tangent is y minus 8 is equal to blank times x minus 1. So we know a lot of the equation already. We just need the value of the slope. The slope is dy dx. But this is parametric, so it's really dy dt over dx dt. There's that third party, that parameter that we have to consider. Well, we know the value of dy dt, it says it's negative 7. Now that's going to be over. We know dx dt, it's 3 plus cosine t squared. So we need to divide that by 3 plus cosine of 4. We're doing this when t is equal to 2. Negative 7 divided by parentheses 3 plus cosine of 4, and we're going to make sure that we are in radians. So mode, we're in radians, we're good to go. So negative 2.983. There's the equation of the tangent line. Find the speed of the object at t equals 2. The speed is the magnitude of the velocity vector. That's how you find speed of a parametric. That's the Pythagorean theorem. That's the square root of. We could do the derivative of y first if we wanted to. It doesn't matter which way we do this. That's going to be 49 plus 3 plus cosine of 4. We're doing this at time t equals 2, 4 squared. So it's the square root of derivative of y squared, derivative of x squared, plus a derivative of y squared. So now we can find a value of the speed. Square root of 49 plus 3 plus, oh yeah, I already squared that. Cosine of 4 squared. 7.383. 7.383 feet per second, miles per hour, whatever the values, whatever the units would be. For t greater than or equal to 3, the line tangent to the curve at x, t, y, t has a slope of 2t plus 1. Find the acceleration vector of the object at time t equals 4. I need the acceleration vector when t equals 4. Well, that's the derivative of the derivative, acceleration. I need to take the derivative of this right here, 3 plus cosine t squared. 3 plus cosine t squared, which is negative sine of t squared times 2t, right? Chain rule. And we're going to plug 4 in there. So negative 8 sine of 16. Negative 8 sine of 16. So the acceleration vector, the acceleration at t equals 4 is 2.303. That's the x. I need to find the derivative of y so I can take the derivative of that, plug in 4. Well, we know that slope is equal to dy dx, which is dy dt over dx dt. They tell us what the slope is. The slope is 2t plus 1. So 2t plus 1. They tell us what the overall slope is. We're trying to find dy dt. We're trying to find this piece right here. Dy dt, and that's going to be over, this is the derivative of x, over 3 plus cosine of t squared. Well, now just by multiplying, we know that dy dt is equal to 3 plus cosine t squared times 2t plus 1. Now we need the derivative of that though, because that's the velocity, we need the acceleration. We're going to evaluate this when t is equal to 4. And we can have our calculator do that. We can just go to math. Number 8. We're taking the derivative with respect to x, at least on this. And then we have 3 plus cosine of x squared. Oh no, I want that right here. Another parenthesis, and then times 2x plus 1. With respect, or no, not with respect, but we're evaluating now at 4. 24.814. 24.814. So we finally got it. We finally got the derivative of the derivative. And evaluated at 4. That was kind of involved. Any questions on that concept there? Okay, cool. An object moving along a curve in the xy plane has position xt, yt at time t with, on this one, they give us an equation for the derivative of x and the derivative of y for 0 to 3. At time t equals 2, the object is at position 4, 5. So there's the anchor. We've anchored it down. We have a position where this function is. A, write equation for the line tangent to the curve at 4, 5. Y minus 5 equals m times x minus 4. We need m is equal to 3 sine of, where are we at? We're at 2. So 3 sine of 4 over cosine of 8. 3 sine of 4 divided by cosine of 8. 15.604. Find the speed of the object at time t equals 2. Speed of a parametric equation is the magnitude of the velocity vector. We have this vector, it has a certain length. We need to find the length of that vector. Well, that's Pythagorean theorem. So square root of cosine squared of t to the third plus 3 sine squared of t squared. Oh, but that's evaluated. I guess I could have put 8 here and 4 there. 8 there, 4 there, because we're plugging 2 in. Square root of parentheses. I need cosine of 8 squared plus 3 sine of 4 squared. 2.275. Find the total distance traveled by the object over the time interval 0 to 1. To find the total distance, it's the integral, in this case from 0 to 1. So we're finding the length of the curve, in other words, the length of the curve. And that's square root of, for a regular function, it was 1 plus dy dx squared when we have a normal function. But this is parametric. So I need the derivative squared cosine squared of t to the third plus 3, no, I need 9. Oh, wait a minute. Find the speed of the object. Oh, I wrote this wrong. But when I did it on the calculator, it ended up squaring the 3 there. So this should say 9 if I write it like that. If I write it like 3 sine of 4 squared like that, then I'm okay. If I had written it like this, under here I'm okay. If I write it as sine squared, I forgot to square the 3, even though I actually was okay when I did it on the calculator. Everybody understand? I don't want to confuse you. Everybody okay with that? Okay. So now if I'm going to write it as this notation, I need to make sure I put a 9 there. And it's going to be sine squared of t squared dt. So we go to math number 9, 0 to 1. Square root of, I need cosine of t to the third and that squared plus, I can do this, I can do, there's an option, right? Sine, or not 9 sine, but 9 sine of t squared, and then that squared. Whoops, delete that out. I need to get all the way over to here. Dx, enter, 1.458. And last, it says, find the position of the object at time t equals 3. We know that when t equals 2, we're at 4, 5. Find the position of the object time t equals 3. So the position is going to be 4 plus the integral from 2 to 3 of the x is cosine of t to the third dt. That's the x. And then the y is going to be 5 plus integral from 2 to 3 of 3 sine t squared. So we have to back up. We have the derivative, we're backing up to the position. So we're taking the anchor point and we're adding on the displacement. That's the displacement, how much it moved. 4 plus, math number 9, 2 to 3 of cosine of x to the third. Don't have to square anything here. X. 3.954. So it actually went backwards. The displacement was negative. 5 plus, math number 9, we're going from 2 to 3 of 3 sine t squared. 4.906, 4.906. So both of them ended up going backwards. Any questions on that concept? It's where you are plus the displacement. How much have you moved?